It's a very windy day today. This makes me wonder, where is the wind coming from? Where is it going? On Science with Mr. Code today, why don't we investigate the science behind the wind? To understand wind, let's try to make it really simple. Have you ever thought about what wind really is at the most simple, basic level? Really, all wind is moving air. Air that's moving from one place to another. Why would air move from one place to another? Well, in this demonstration, I hope to move us toward that understanding. So for this model, I'm using a big bowl full of room temperature water. I'm using a small container of cold water. And I've got another small container here which I'm going to fill with hot water. And I'm going to use these two colors, red and blue, to help us distinguish those temperatures. So, first I'm going to take my cold water and flip off the cap. I'm going to use blue food coloring to help us distinguish that cold water. Cold water is not very good at mixing food coloring because molecules of cold water are not moving very fast, so I'm giving it a little bit of help. Oops, little spillage. That's okay. Okay, now in my other container I'm going to pour the hot water. Steady hand, Mr. Co. Wow, well done. All right, and in this container, I'm going to put red food coloring. Notice how much better that the hot water is at mixing that food coloring in. And still, I'll give it a little boost. Okay, so we've got cold water, which is colored blue. We've got hot water, which is colored red. What I'm gonna do next is submerge both of these containers into our room temperature water here. And I want you to observe what happens with each of these colors as time passes. Okay? First, we'll put in the hot water. I'm gonna put the camera down over here so that you've got a nice view of the whole bowl all at once. There we go. Hot water going in. Let's watch what happens. Do you see all of that hot water rising to the top of our bowl? Isn't that interesting? Okay. Now let's try the cold water. Pretty different, isn't it? Instead of rising out real quick and going to the top of the bowl, the cold water is staying right down there at the bottom. Friends, this phenomenon is happening because when water is heated, it becomes less dense. That is, it becomes more spread out. When it's less dense, it wants to rise up through this room temperature water till it can't rise any further. Cold water, on the other hand, is more dense. Since it's more dense than the room temperature water around it, it wants to sink down to the bottom. Air behaves in just the same way. This bowl of water, along with the hot water and the cold water, is my model for the atmosphere. The atmosphere is the layer of gases that surrounds our planet. When air is heated, it also wants to rise. And when air gets cooler, it also becomes denser and wants to sink. This phenomenon is what's known as convection, and it is the driving force behind the wind. Convection is always happening in our atmosphere, causing warmer air to rise through the atmosphere higher and higher and higher, and causing cooler air to sink lower and lower and lower. So we're getting this constant motion up and down in our atmosphere. Air is always moving up and down because of this convection. But we know wind as air which is moving side to side, isn't it? How can convection, like we've just seen in this bowl, cause air to move across the ground side to side so that we can feel it? We might be able to learn more about this by visiting a certain website.
I found this map at a website called Windy.com. It shows the direction in which the wind is blowing today. See those moving white lines? Those are moving from northwest to southeast, and they indicate the direction that the wind is blowing. Zooming out, we can see more of our wind's journey. It begins in this area of high air pressure over Missouri. And if we follow the white lines, we can see how they travel eastward. They cross our city, Washington, and then they keep going out into the ocean and then swirl up north into this area of low air pressure. What is air pressure, and why does wind flow from high air pressure to low air pressure? Let's go to the whiteboard.
When hot air rises, it rises up through the atmosphere this way. It's heated, of course, by our old pal, the sun. All right, now once that warm air is high enough off the ground, at a high enough elevation, it's going to cool off. And so it becomes cool air. And we know that cool air wants to sink because it's more dense. Okay? So we know that wind is air which is moving side to side across the ground. Convection is when air moves because it's being heated or cooled. Heated air rises, cooled off air sinks. We feel the wind as that cool air moves across the ground to fill in that empty space that was left behind by the warm air rising. This is where air pressure comes in. On the map, we saw indications of low pressure and high pressure. Those simply indicated whether there was a lot of air pressing down on the ground or not as much air pressing down on the ground. Now, which of these situations do you think matches up with high pressure and low pressure? If we consider the ground to be right here. You guessed it. This is our low pressure area because there's more air, there's air rising up off the ground. It's not pressing down on the ground as hard because it's rising up through the atmosphere. And where that cool, dense air is sinking and coming down to the ground, that's an area of high air pressure. So, in sum, when we feel the wind, we're feeling air moving from a high pressure area to a low pressure area to basically fill in the gap that this warm air left behind as it rose up from convection. This cycle is going on all the time, all around the world. And you can always look at that map at windy.com to see exactly where the high and low pressure areas are around us. Something you might remember is that wind flows from high to low. It's almost like a little poem. So, my friends, next time you hear the wind or feel it blowing on your face, just think, that's convection at work. Wind flows from high to low. I'll see you next time on Science with Mr. Call.